Right, morning guys. Kieran Wood here from Efficient IP. Welcome to the Efficient IP webinar on how you can accelerate your cloud service deployments with DDI automation. As I said, my name is Kieran Wood. I'm Director for the UK and Northern Europe. And I'm joined today by one of my senior solutions architects, Nick Fennell, who I will introduce in a moment. Before we begin, I'd like to go over some general housekeeping items if I can. If you are joining us live, you will receive a follow-up email with a link to the replay, the recording of this session today. Hope you can share this with this link with your peers or your colleagues so they can view this webcast on demand at their convenience at another time. Also attached to this same email will be a link to download a copy of the slides from today. If you wish to ask a question during the session today, please feel free to do so. Use the chat box at the bottom right of your screens, and we will take questions and answer these at the end of the presentation, if that's okay. So just going into Efficient IP and who we are as a business. Some of you may have heard of us, some of you may have not. So who are Efficient IP and what do we do? In simple form, we're a global network automation and security company specializing in DDI. DDI is a shorthand abbreviation for the integration of DNS, DHCP and IP address management into a unified service or solution. DDI compromises the foundation of core network services that enables all communications over an IP-based network. We do this by three main areas really. Simplifying network management by automating control of the infrastructure and the apps, protecting users, apps and data by securing DNS to ensure service continuity, and optimizing routing of traffic from users to applications. There you go. So Efficient IP in brief, as I was just discussing. Efficient IP, we're one of the world's fastest growing DDI vendors. We help organizations drive business efficiency through agile, secure and reliable network infrastructures. Efficient IP has continued to support our reach internationally and globally since our inception in 2004, providing solutions, professional services, and 24/7 follow the sun support all over the globe with the help of global business partners and our partner ecosystem. This ensures an efficient and successful deployment for all of our customers. Efficient IP as a business is committed to thinking differently about the DDI industry. We like to think innovation is in our DNA. Our goal is to create value and efficiency for our customers through heightened security, advanced automation, and greater simplicity. I'm just going to do the general slide where we talk a little bit about some of our existing customers. So in the next slide, you can see a small graphical representation of the businesses across a variety of industries and government sectors globally who rely on our technology. It's important to note here that while some of the names here are household global brands, which many of us will recognise, we have a huge amount of customers from all verticals and all different sizes, which illustrates our ability to scale not only up, but scale down, and our adaptability to suit our customers' specific drivers. Okay. If there's a customer who may be a lot bigger in your segment, and you guys as an organisation are smaller and you think, do we scale up, do we scale down? Yeah, have a chat with us. Nick and I will be more than happy to have a chat with you about how Efficient IP as a business work with different customers across all the different market segments. So if I'm going to hand over to Nick now, Nick's going to actually work on the DDI automation slides for you from a technical perspective.
So the topic today, it's around challenges for cloud management. For Efficient IP, it's a big topic, and we recognise that for the majority of the world, if not the entirety of the world, cloud adoption is one of these things that's on the up and up. We see it across all markets, all verticals. We see everywhere that there is if not a drive, there is a serious interest in moving towards the cloud. But there's also quite a lot of reluctance to throw all of your eggs in someone else's digital basket. So we find ourselves in a hybrid type environment, and we refer to this as being like the hybrid and the multi-cloud. Now, with the hybrid cloud comes a raft of complications and headaches. You'd think that moving your entire organization out to somebody else's network would be simple, but unfortunately it's not. We have to worry about many different things. There's many different categories of headache that we have to engage and start to dismantle. So Basic things like inventory and classification, or provisioning, automation, some things that are on a local network quite easy, but when you begin to rope in wide area networking and remote networks, keeping track of things, configuring things, and then how you automate are not simple approaches. And things like security, again, it's not a straightforward problem. Using different tools, different approaches, different platforms, brings with it complexity in itself. So the first part of the headache, which is the management requirements, that's one headache in itself. But then the fact that we might have different tools, we might have our own tools that we've developed, or it might be that we have to use a tool by the provider itself. We might have all of these competing demands, which effectively lead and essentially lead into a clashing set of outcomes. So multiple separate repositories for information, siloed management across each cloud or each instance of technology, and then restricted automation capacity. So we try and group these up into sort of like three challenge groups, so that we can make some sense of what we're trying to attack. So the first group that we're seeing is focusing around visibility, consistency and policy. The second group is around the rollout. So whether it's like a multi-tenanted or it's like a DC, that's a big headache. And then security, that becomes another challenge that, well, the challenges become bigger. There are challenges already, but they become bigger when you start involving moving pieces. So the challenges of visibility, consistency, and policy control cause managers to lose control, not just of their minds, but of their networks. So in an instance where we've got a traditional network with a traditional IPAM, well, we want to tie the traditional DCs into that traditional IPAM for the traditional network. Because otherwise, we end up with incomplete visibility, policies not being adhered to, configuration errors, unauthorized access to the network. So if we don't have these components all singing and dancing in the same way, then we open ourselves up for pain. Now, where we see this as well is in the service, in the rollout of service, how complex things become. If we're not just deploying virtual machines on, say, VMware Hyper-V internally, and we're now having to spin up cloud instances with different profiles, different configurations, different requirements, different VPCs, different security, it's not just a straightforward task anymore. That we've gone to the old JFDI days of IT. Everything has to be policied and processed now. There's so much accountability. Everyone wants to make sure they've done everything up front. So it means that full configuration is extremely time consuming and error prone. Things move too fast. You can't always predict what a perfect configuration will be. You might hit capacity planning issues because you've not got visibility of what's going on in the cloud anyway. It might be a complete and utter headache to try and enforce a standard across different vendors, different technologies, when they're not all talking the same language or using the same technology. And then ultimately, it leads to rollouts being slow. Because if you can't just throw a network service up or throw a server onto a network, you've got all these hoops and gates to go through, then yeah, everything starts to slow down. So DDI becomes an enabler for your cloud journey. It solves the visibility, it solves the control, and it solves the automation headaches that we're facing. And even efficient IP are subject to these pains. We're trying to spin up labs and training departments in virtual environments, and as you can appreciate, when we're deploying new labs, there's quite a bit of work there. So DDI is a foundation for cloud services. Even as a vendor of DDI has a massive impact, and our virtual estates and such are not the largest. So it helps by increasing accessibility for network and applications. DDI helps by improving agility. It means you can scale out fast and you can automate. And then equally, it improves security, because we can see who's connected, where they're connected from, and maybe what they're talking to, maybe how long they've been on the network or who put them on the network. So these all tying together, it means we can begin to ask questions. We can ask questions because we have a central IPAM repository, a single source of truth. Everything goes into one place, whether it be on-prem or off, whether it be information we're storing on applications, devices, or just IP-related info, it all goes in there. It synchronizes with your cloud environments so that we get rid of the silos, so we can control consistency and improve the auditing, and so that the golden records, which are basically your most important assets on a network, these things are maintained and they're looked after. Nobody likes to see their main website domain going offline, and that's an example of a golden record. For us, www.efficientip.com is a golden record, because without it, nobody gets to our website and sees the glorious and lovely things that we do. Many different examples of that, but what we want and what we strive to have is a single pane of glass to view them all. We want to see all of these records and control them all, but not just our golden records. We want to see everything. We want the unified management of on and off prem. We want the access from a single viewpoint. We want it to integrate our DNS, DHCP, and IP into a single process. We want things error-free. We want things policy-driven so that we can benefit. Because really, that's what we're here to do. Efficient IP, we're here to benefit, not ourselves, but yourselves. We benefit by hearing and seeing, people's lives get easier in the general sense, because we're making resource utilization better. Mitigate shadow IT I love, because that's doing away with the overhead, the duplication of processes, having to forward things up email chains just to come all the way back down them. That leads directly into simplification of the management. If you've got less hurdles to jump, things become easier. If everything's in one place, well, we can begin to enforce corporate standards across a unified platform, across a shared base. And through having control, visibility, and now some generality over things, we can begin to increase the deployment velocity. So we want to get away from complexity. We want to be able to accelerate deployments with DDI automation. And how do we go about doing that? Well, we come into the life cycle. So DDI becomes a critical component of the IT services lifecycle management, just to read the title word for word, but it's a true point. Because if I get my little highlighter laser pen thing and I say that basically DDI sits right there, and that all of these things around it feed out. I mean, we have the DDI on the outside, but we're talking about a central repository of information. So really, these things are on the inside of this circle. But as an image goes, we want to make it so you can read it. But the point is that it's an end-to-end. So you request and then you end up in an archive. So you create and then you destroy. Now, when you're creating, you're pulling data out of IPAM, but when you're destroying, you're removing data. So it's completely circular. And if you follow the path, and in an automation lifecycle, you could have things like Puppet or Jenkins or Terraform or Ansible or Morpheus, whatever it is. This isn't limited. These are just the ones that we put on the slide. You fall into a 4-step deliverable process or a delivery process. You can design what you're trying to do, you can deploy what you're trying to do, we check it, and then we reconcile it, and then we carry on going. It's fully circular. But to do that, it means you need a cloud management platform. You need to have some sort of idea that the infrastructure exists as code, some sort of software definition. If we can see that, automation becomes possible. And then continuous integration of new things becomes then just a hair's width away, realistically, because DDI is literally the cornerstone, not just for this collaboration, but for all collaborations. We see this in the automation provisioning layer. It's where we've got our 3 layers. We've got our blue layer, our orange layer, and our green layer. High-level orchestration at the cloud level. Software-defined networking controller. So this is like your switch fabric, your router fabric. Configuration manager. So this is Ansible or Terraform or something similar. We use the 3 levels, or you use the 3 levels, but tie them all back to the DDI, and you feed in information throughout the process. So it's not static. It's that the configuration sets what goes on the controller, which then sets what happens on the cloud. So you start from the lowest level and you end up at the highest level, and it's all underpinned by DDI. Now, where that lands you, or leads you, is into zero-touch networking. So I used a good example, which is basically spinning up data centers via Alexa. Because if you can connect APIs together, then it doesn't matter where you're driving things from. I could effectively spin up a network from my watch. If all of the methodology has already been predefined and I'm literally just setting a variable, i.e. how many networks would I like, answer equals 5, well then the automation goes and creates 5 networks and reports back when it's done. There's no reason why I could not shout, Alexa, create me 5 networks in data center 3, please. No reason at all. And it's a pretty out there example, but why not? The DDI allows us to have this repository of actionable DDI data and metadata. It gives us the full DDI function, and it gives us a secure API access, which is protected by role-based access control. So this is our API I'm referring to. Sorry, I realized I missed the title there. So the API gives us this ability to integrate, gives us this ability to perform zero touch using things like Alexa, because it has a repository of actionable DDI, complete access, and it's secure, and it's standardized as well. So Open API and Swagger. So again, if you are wanting to roll out a quick deployment, a cutting edge deployment, something really quite groundbreaking, then we have all of the standardized open standard compliant component that you need in order to do that. So you don't have to come to us and relearn everything. We just enable you with a DDI platform that's able to drive deployments, through simplicity, through pre-configuration, by pre-planning. So if it's VMs, tenant softwares or applications, you can spin those up. There's span error-free configurations because we've done all of that work first. It's consistent because we're using automation, so human error can't sneak in. And it's all enforced by policy. We've got global visibility across all of our environments. We've got better scalability now because we can see what's in our DDI, what's being used, what's not. And we become more highly available because if our DNS and DHCP services, which are integrated, are now hosting more accurate data, less garbage, are configured better, are better integrated, well, it makes sense that things become more stable, more highly available. So all of these points here are the summary. This is the summary of our DDI benefits. Not the exhaustive list, but certainly the sort of highlight or the high level that I would certainly want to focus on for most, if not all, customers. Now, to give you an example of how automation and DDI can be used, we've got a bit of an abstract demo. Now, the demo, it works around a requirement to effectively build a dynamic video editing suite. We tried to do something a little bit different, not just spin up a few switches or a few virtual machines that do nothing. We tried to show that using DDI as a center pin or as a center hub or engine, you can really do anything. So we're building an animation suite or a video editing suite, I should say. The suite requires lots of resources in the cloud, which is where we're spinning it up. So we have a requirement to remove it when we're not using it. We want to supervise everything that's going on. And we have an objective to deploy or to deliver a 1080p image that's been rendered via a grid deployment. Okay, so seems straightforward enough. We're going to use Terraform as an orchestrator. We're going to use Blender as a ray tracer, or as the editing aspect. And then we're going to use the AWS cloud as our target for our virtual machines that we're going to be creating. So first of all, demo components. Number one, we need a grid or a management tool for our Blender software. So we have that in the form of the Blender Grid Monitoring app. We have defined what our distribution grid will be. So we've had to set a little bit of configuration for Blender just to let it know what its potential scope is. We've defined our infrastructure orchestrator as being Terraform. And this is also talking to our cloud platforms. This has been linked to our AWS account. And then we also begin to link it into our DDI solution. So first things first, we build the environment, the networking. The orchestrator, now that they have a basic of API connection established, they can talk to each other. So the orchestrator asks the IPAM for an available subnet. When it gets it, it goes up to AWS and it creates that subnet or those subnets within a VPC, which is like a virtual cloud, so an application cell within AWS. It gets all of the information from IPAM and it records back everything that's been configured. It then creates a DNS zone. Again, the orchestrator, this is Terraform, creates a zone for this application. And at that point, we're almost ready to get going. So first things first, now we've got our components in place, is we want to add the grid manager. So this is like our software editing management tool. So we tell Terraform that we want to build a grid manager, VM, and do everything else, install the software. That's the job that's been configured to do. So we click go on that. So Terraform does that. It builds the VM, spins it up, installs the software, and then it communicates to the IPAM to log what might be the IP address, but to definitely record that we have just created a virtual machine out in the cloud. So on our platform, we have something called Device Manager, which is an asset registry tool. It allows us to record instances of hardware with interfaces and MAC addresses and things. So our IPAM in this instance, or our solution in this instance, is recording the IPAM data, physical asset information, and then it's also taking additional IP name metadata as a response from the AWS cloud when the information we've configured has been confirmed. So it's all being sourced from here, but once it's been confirmed by the AWS as being in use, we then report back to the DDI and say, yes, it's now in use. So when we've got our networking established, we've got IP addresses configured, we then want to start updating the DNS, so creating A records. So that's what happens next. Terraform and the DDI instigate the creation of records, and then it means that our client application, which is our monitoring app here, is then able to talk to the master server out here. Because all of a sudden, this is already connected just by networking, standard networking configuration to its gateway and to its DNS servers and whatnot. So this is trying to communicate to a DNS name. It suddenly can resolve it. Well, all of the networking exists because we have a proper, AnyPath or Fast Connect or whatever it is to Amazon. And the software can then talk to the master. So they can then start chatting, and it means that when we can move into the next bit. So what we then want to do is add some workers. So we've got a manager. We have our manager. We ask the orchestrator to then build some workers. So it goes and does that in the same way. The DDI gets told about what's going on. The workers can then talk to the master. So master here, workers here, they can begin to communicate. And the monitor, the client software is watching this all the time. It's seeing, obviously, all these communications are going on. And all this is being spun up purely by automation right now. Now, as I say, when we've done our job, we're not allowed to leave things idling on AWS. So first things first is that when the job is complete, Terraform eradicates everything on Amazon or Azure or Google Cloud, whichever one you go for. But the point is the job's been done. So Terraform says, right, well, scrub that, delete everything because we don't need it anymore. It's all just completely garbage after the job's done. It goes to the DDI and does the same thing. Kills off all the, the IPs, the names, the networks that were in use, dissolves any DNS records that were created, and then leaves the platform nice and clean. Now at this point, we've got a bit of a click through to go into. So it's like a little bit of a demo that I put together. So this is our live system. And I'm showing here that we're going into our IPAM, which we call Strange World. So this is our IPAM for our general network, our hybrid network. And I've got a couple of networks that I've tagged with AWS, which I'm just going through to show that whilst I have the subnets defined, the /16 for the entire region, I don't actually have any subnets created. So I have what effectively is a block, an addressable space that doesn't have anything currently addressed into it. In my device manager, I've got 6,599 or 6,600 devices, but none tagged with AWS Cloud, so everything's sort of local. And then equally in my DNS that I've created an architecture for this, I have no zones, no records. So completely empty basically. Now I launched my client application, my Blender Grid monitor, but it can't talk to the manager because there's no DNS. There's no IP, there's no DNS lookups, you know, there's nothing. I've just got basically a client floating in fresh air. So I jumped to my our Terraform server. I run a command to initialize, which does a few things based on what we've told it to do. So you know, it's linking to AWS, it's linking to Solid Server, it's got our API schema loaded, and I then tell it that I want to create the manager. So it's done 32 or something jobs, and what I begin to see on my client is that the manager, the client software was able to resolve, and it's able to do that because in our IPAM, I've begun to create data. So I've got networking information in my IPAM. In my DNS, I now have a zone. So I can see I've got a zone there with some records that have been created. And this has all just been done by Terraform. As you remember, this was all empty beforehand. So this is all just in those 2 commands on Terraform, it's created all of this. I've now got a device in AWS. And you can see the availability, EU West, T3 Nano, Cores 1. So I've got metadata back from Amazon about what's actually been deployed. Now, I've got a worker, I've got my manager, I've got my monitoring app, but I've got no workers. So next jump is we go back to Terraform and I run the command to create me 4 workers. So it does its work. I can see some information back from AWS from Terraform on what's been configured. This gets shot across to our IPAM, and I can see the devices that have been created now. I see the DNS names that have also been created thanks to DDI. And then our IPAM will also see that the number of hosts now used has gone up. So I've got 6 used IPs in this subnet now. So 3 workers or 2 workers in that one and my manager. And then in another subnet, I have another worker. And this is because the VPCs or the regions split service across different subnets. Now for our IPAM, we just update whichever subnet takes the IP. So it doesn't matter to us essentially which subnet things are deployed into, because everything's created dynamically anyway. So as long as we track it and record it, that's the main thing. So we've got workers that we've just dynamically created now. We can see 3. We're expecting 1 more to join, which won't take a minute. But what these workers are doing is they're taking jobs now out of the queue. So you see 97 jobs in queue, 3 servers, ETA 00. Now, as the workers begin to join, they begin to process their job, and the image begins to render. Now you see we've got 4 servers now locked in, 4 workers, but it's going to take a long time. So we can speed this up. Well, let's by adding, say, 12 workers, so 12 more. So that's going to leave us with 16 workers, which in theory should be enough to crunch some serious amount of image or some serious media. So again, we run the command. We see that in our AWS console, we've got 17 instances. And we see all these with their various different, 2 different profiles actually. We just have T3 Nano and T3 Small being used. Initializing is a lot of them, but running is the case for most. We jump back to our DDI and do a quick refresh, and we see more DNS names have been created. We've got 10 in one, 8 in one, 8 in another, because of the split with the networking. Our DNS zone has all of the records, as we would expect, and our device manager now has all of the nodes created from AWS. So this is keeping a central repository. We keep it all in one place, and we'll see now that on our management server, this really picks up now. So blink and you'll miss it in some ways. We go from 5 servers, and then we rapidly go 6, 7, 8, 9, 10. And we'll see then that this image starts absolutely flying through. So we get to 8, and then it should really start going, I think. Yeah, here we go. Cool. So the difference that a few extra machines make. So we see now 16 servers, the jobs are falling out of the queue, the render time is collapsing, ETA is just absolutely dissolving, jobs in queue 0. See the servers being wound down because the queue's basically complete. One more block, and then that's it. We're done. We've rendered. So again, it's a bit of an abstract for someone like a DDI company to be showing an image of an M Sport BMW. But the point is that DDI isn't just about us, not just about joining workstations to networks to get Active Directory connections and things like that. It's about driving automation. It's about the back-end mechanics behind this software require networking components, but it doesn't require people or engineers to manually configure those components. If there's logic that can be instilled and there's process that can be enforced over the top, then it's very, very, very feasible and completely possible that these things are automated and driven. So most important thing at the end is that we destroy everything. So we don't want to leave things running because we get charged, or you get charged. And if it takes only a few moments to spin them up, well, where's the logic in keeping them running? If it's as quick to delete as it is to create, then you might as well just delete when you're done. And that's unfortunately something that we've never really been able to get into as an industry. Creation is 10 times that of destruction, if not 100 times. So we don't want to destroy servers for no reason until we know we're never going to use them again. And this is why we end up with hardware and software sat running in places without usage, because there might be one case for it being required. So in the IPAM, in the DNS, in the asset management, we're just cleaning up basically. All of our networks are gone. We're back to the start. Our DNS was empty. Device manager's gone back to being completely empty again. Well, for the AWS cloud, but we've still got all our local devices. Because equally, we're not managing these assets on the top end anymore. On the AWS platform. So there's no reason to keep that information in place. Again, like I say, if it can be created as quickly as it is destroyed. So some takeaways then, and I hope that all made sense. But some takeaways, and this is my mantra. People that know me and speak to me will know that I've been saying this for ages. You cannot control what you can't see. It's just impossible. You need an accurate inventory of everything, deployed VMs, IP-related infos, so that you can make decisions about your network. Not just accurate decisions, but decisions full stop. Because without all of the information, you could be landing yourself in failure or in dire straits. So automate the life cycle, control the IP resources through DDI, and benefit from massive time savings. Benefit from guaranteed error-free configuration because you pre-tested the configuration, you know there's no errors. Integrate DDI into the network and benefit from security. You can ensure compliance of your ecosystems through policies. And last thing, the key message really is that DDI is an enabler for accelerating rollout of apps and services. I'll read it word for word. And by apps and services, applications, network-based applications, email, websites, telephony, CRMs, rendering suites. Anything that a user connects to is what we consider an application, if it's something they're doing for production or fun. Anything that they need to get on the network is a service, and DDI underpins it all. So at that point, we break the flow and we jump to some questions, and we have had a few.
Yeah, thanks, Nick. Yeah, guys, as I said at the beginning, we did encourage you all to ask some questions throughout the presentation by Nick. Some of you have used that facility, so thank you very much for posing some questions. Nick, I've got some questions here from the audience, which if I read out and you can give a technical, competent answer to, because you're far more qualified than I am to do so. One was, will there be an API LTS version system in place? Currently, we run a couple of times in the situation that calls changed and we need to rebuild the automation.
Oh, okay. So yeah, we do. So we are adamant against making changes within major versions. So within the release cycle, we will have to change things. Calls do get deprecated, technology does change. Certain calls do become, well, I use the term better. But there are sometimes positions where we have to change. Now, what we do not do is change these through major versions. So if you deploy at version 7, the API throughout version 7 will not change. Equally, if you're on version 6 or version 8, which we haven't released yet, but when we do, the API doesn't change from a fundamental or a structure point of view within version. There might be slight tweaks that need to be made, but we always capture this within important notes and release information that come with a release to advise of any alterations. We understand that API is a make or break function. It's not something that we can mess around with in production environments, and we respect that it is nothing but annoying when a vendor tweaks things and doesn't tell people. So we're pragmatic about this. We're all engineers, so we try and give as much head up that something is coming, if it is coming. But generally, as I say, we try not to make any alterations within a release stream, so that customers are not having to scrabble around and react to our internal design principles.
Excellent. Thank you, Nick. Another question from the audience. In which version is Synchro with IPAM and AWS available?
So 7.2, which we've just released. So we did have this via API for quite a while, for a good few years now. But what we have matured into, which is always a great thing to say, we've matured into a much more out of the box, click and go type approach now. So you are able to link up your Amazon AWS account details, and this is the same for Azure soon as well. Able to link in your account details and then effectively do a synchronize and populate of our tool. At that point, data can be pushed bidirectionally. So if we're creating things in our IPAM, like we've just seen in the demo, that information can be ratified up into the cloud environments and then kept in sync with our platform. So that's available from 7.2 again, which is currently our most recent release. But we will be enhancing our capabilities in future releases, as we always do.
Excellent. Thank you, Nick. There's a good question here that's come in. In the demo, we see that the IPAM updates the DNS services of Efficient IP. Can the IPAM of Efficient IP be integrated with more technologies?
Yes, completely. So we have an ability or a function called multi-vendor support module, MVSM for short. What it allows us to do is to talk to predominantly Microsoft and ISC. They're the two biggest things that we go for as an alternative technology, and we have a sort of a direct path to. With Windows, for example, we connect to the XML RPC service. It's all native. There's no agents that are required, and the XML RPC is like a Windows API. So with that, we can gain full integration rights to the DNS DHCP services, integrate them to our own DDI offering without actually having to dislodge the Microsoft element itself. And the same is true for ISC. Now, where I can expand on that a tiny bit is that if you have a technology that is API aware and has a DNS DHCP engine on it, then again the scalability or the scaling integration potential is again greater, because you've got two technologies in that instance that talk API. So yes, we do integrate with other technologies. We have some which are very, very straightforward out of the box, but then we equally have an API that could be integrated to anything in most cases. Okay,
thank you. Another one from the audience, which is probably around our services and what sort of support they can expect from Efficient IP, but what support is offered by Efficient IP for automation and orchestration?
Okay, yes, it's a good question. So one thing we are quite different on is that we consider ourselves to be consultants first, not salesmen, not solution pushers like myself. You know, I do still retain the title engineer, even though it says pre-sales in front. So support that we offer is consultative, it's development and deployment. We offer it for all projects, and we provide and develop plugins for our ecosystem that enable things like automation orchestration to be picked up quicker. So whether it be like vRealize for VMware, or the Hyper-V extensions, or whether we're tying in like through Terraform or Ansible, we recognize all of these are our initiatives and projects that we want to support. So we provide our professional services department as a facilitator or as an enabler for customers and prospects to do what they want to do. Now we know our solution and our API better than anybody. If we know our technology and you know your technology, we can have legitimate conversations about how we join the two up. So support we offer is full. From a support perspective, just generically, it's 24/7, 365, follow the sun. And any customized or any deployment work that we do is all backed by our support department with full handover. So we're not going to be doing scratchy back of a cigarette packet type deployment ideas, bespoke ideas, and then leave support out of the scenario so that you're having to describe customizations. Anything we do is completely backed by the business, and is completely supported by the business, to keep customers moving forwards, really.
Excellent. Okay, one of the final questions, Nick, I've got from the audience is, does the Solid Server API require any special licensing?
No. It's the answer to that. No, it doesn't. No, it's part of our base license. And in the slides earlier, I was showing that it's Open API compliant and Swagger compliant as well. So yeah, completely available. We have SOAP and REST. We're always expanding this thing out, as I say, not within major versions, but yes, part of the base license. So no extra licensing, no extra fees, no hidden. There's no hidden agenda with that. The API is how our GUI drives our own product. So our own interface, graphical interface, uses our own API to do everything that it can. And that's how I know that we don't change our API within major version, because we break our own GUI. So we almost restrict ourselves from these things by making ourselves a customer of our own solution. And I like the ethic because we end up with a truly organically designed product.
Excellent. Thank you,
okay.
Nick.
That's okay. So
I don't believe we have any further questions from the audience. I do have one. I've got one which is basically just around the API access. Okay. Yeah. So someone was asking, yeah, basically, so with the API, how can we restrict access? Not wanting to give access to everything, basically, which I think is a very, very good question, because we spoke a lot about API and automation, but no one wants to give AWS access to their entire DDI estate, for example. So I'll pick this one, and then yeah, this is the last one. So the question: how can permissions be controlled for API? Well, we have what we call our role-based access control engine or mechanism. Now, our role-based access control is able to very granularly filter out and control what access can be given. So whether it be by GUI or API, access to the data within the solution can be fully regimented and regulated, so that if you've got a user logging in via the GUI, they could maybe just have reporting access to a single subnet. But if you're integrating with Amazon, you could restrict the Amazon account to only have access to the networks appropriate to Amazon, or to the DNS zones appropriate to Amazon. So Amazon doesn't get full reign over your DDI, where it can start creating and deleting data from anywhere it feels. We use our role-based access control, our RBAC, to fully tie down what any account can do, and it's fully logged, it's fully audited as well. So when you're looking through what accounts have been up to, you see it all by function. So have they been adding things or deleting things, and where? It's all logged in terms of when they did something, what date, what timestamp, so that we can remain in control at full times. I mentioned at the start visibility. Well, visibility is great for data, but it's also great for people. We need to see who's doing what, when they're doing it, and why they're doing it.
because if we don't understand motivation, then we don't understand anything. So yeah, the API access, fully controlled, fully regimented. It's a zero leak policy. So unless you have read access to something, you don't even see it displayed. So there's no clicking on things and getting read only or anything like that. So that's it, really. You know, the API is very core to the product, very extensive, very scalable, and DDI automation is the way to is to drive, you know, your network. So yeah, on that point, 45 minutes.
Thank you, Nick. I don't believe we're showing any other questions, so I'll go ahead and wrap things up. From Nick and myself, thank you very much for taking time out of your day to listen to us waffle on. Please look out for the email with a link to this presentation and the slides within the following days that will come into your inbox. And if you have any further questions or queries, please do reach out to us. Thank you again, everyone. And with that, we will close this session. Have a great rest of the day. Thank you very much.
Thank you all.